Hey, what's up? I'm Anand Chowdhury from John F. Kennedy Middle School, and today I'm here to talk about how to solve rational algebraic inequations using the sign method. So, let's get started. So, the sign method is used for polynomial functions which are in the form of px divided by qx is either greater than, less than, greater or equal to, or less than or equal to 0. One example of this could be fx equals x plus 1 divided by x minus 1 is greater than 0. So the goal in this is to find some values of x that are actually valid for the inequality. So let's get to the steps that are required to actually complete this thing. So the first step is to obtain px and qx, which is usually given to you in the equation or inequality. The second step, factorize px and qx into linear factors. So if there's a quadratic in the numerator or denominator, you're going to have to solve it into a linear equality. Make the coefficient of x positive. That's pretty simple and straightforward, so I hope you understand that part. Find critical points. Make px and qx equal to 0. So you just want to make px and qx equal to 0 for our next step, which I'll tell you right now. So after you find the critical points, you're going to plot the critical points on the number line. If there are n critical points, the line is divided into n plus 1 segments. The right segment is always going to be positive, the left segment is also going to be positive, and the middle segment is going to be negative, like so. See, these are the critical points that I marked here. The right segment is positive, middle segment is negative, and the left segment is positive. Now let's go on to solving some problems. So our first problem is find the solution set of the equation x minus 1 divided by x minus 2 is greater than 2. So I forgot to mention, it always has to be 0 when you're solving, and in our problem it's 2. So what I'm going to do is I'm just going to simply bring this to the other side, make it negative because it's positive right now. So it's going to be simply like x minus 1 by x minus 2 minus 2 by 1 is greater than 0. Now I can quickly just make this add on to this by subtracting them. The common denominator is x minus 2, and so it'll be x minus 1 and minus 2x plus 4 is greater than 0. Now if we quickly simplify this into negative x plus 3 divided by x minus 2 is greater than 0. Okay, so they both are linear, as we see, and the third step is to make all coefficients of x positive. If we see in the numerator of this inequality, the coefficient is negative, so we're going to have to multiply negative on both sides, which means it's going to end up being x plus 3 divided by x minus 2, because we didn't change anything in the denominator. And since we multiplied negative 1 to 0, it's... Oh, sorry, wait, made a mistake. It's supposed to be negative because I multiplied negative. Okay, but since I multiplied negative 1 times 0, it's still going to be 0. So now we want to find the critical points, because that is our next step, find critical points. So we have to find out what will make this whole inequality 0. I can see that it can be made 0 by putting 3 in as x and also putting 2 in. So if I were to draw a number line here, I can plot 3 and 2, and as it says here, the right segment is positive, left segment is positive, and the middle segment is negative. So this is the middle segment, and the other two segments are positive. And one thing I actually forgot to do is to change the sign. So that was a silly mistake, but I changed the sign now, as I was supposed to. And this sign is indicating that this is less than 0, meaning it's on the negative side, because on the other side of 0 is negative. So I can see the negative portion is in the middle of 2 and 3, meaning that x is here and it's less than 3 and less than 2. And if it was less than or equal to, I would actually write it in a different way, which I'll show you next. So let's move on to our next problem, which is to find the solution set of the following inequation. X squared minus 3x plus 4 divided by x plus 1 is greater than 1. So let's see. It says first we have to make the 0. We can just bring this over and make it x squared minus 3x plus 4 divided by x plus 1 minus 1, because it was positive there, by 1 is less than 0. And the common denominator here is x plus 1. So I put that there, and it'll be x squared minus 3x plus 4, and then minus x minus 1 is less than 0, greater than 0. So now we're just going to simplify this top part up here, as it says, so factorize into linear factors and obtain px and qx. So first I'm just going to obtain px and qx. So I'm just going to simplify this to x squared minus 4x plus 3 divided by x plus 1 is greater than 0. So one thing I'm going to do, this numerator is going to be part 1, and I'm just going to do that off to the side. I'm going to simplify it into a linear equation. So it's going to be x squared minus 4x plus 3. So it's going to be x squared minus 3x minus x plus 3. Now if I quickly simplify it, it's going to be x minus 3 minus 1 and x minus 3. X minus 3 and x minus 1. So now if we continue on with that, it's gonna, this is just a little workbox. Well, what we're gonna get is x minus 3, x minus 1 divided by x plus 1 is greater than 0. And so now we're gonna have to find the critical points. So it's gonna be, the critical points are gonna be for x is equal to 3, x is equal to 1, and x is equal to negative 1. So if I were to draw that on a number line, I have 3 critical points. So therefore it's gonna be 1 is at 3, 1 is at 1, and the other one is at negative 1. But it's not like this normal number line. So what I'm gonna have to do is as it says right is always positive, then I'm just gonna go with the pattern. Okay, now over here it's saying that it's greater than 0, so it's gonna be on the positive side. So meaning it's gonna accept the values between negative 1 and 1 and 3 to infinity. So it can also be written as minus 1 comma positive 1 universe, meaning just joining it together, and 3 to infinity. I hope my video was useful to you, and I hope you learned how to use the sign method. Thank you for watching my video, and I hope you enjoyed. Bye.